In this lesson, we'll explain the settings and the programming process of Siemens PLC. First, after we build a Siemens PLC project, here we configure the hardware according to the practical situation of the equipment. And then click on the Internet address. Here we can see that the IP address of PLC is 192.168.8.1. We enable the system and the clock memory here. Check it here and check it here, because we'll use M0.0 later. Then we build a model bus communication function block. Okay, let's enter this function block. And then we have to build some variables in this place. First, we have to build a model bus TCP static variable. Its data type is TCON IPv4. For the operating parameter, interface ID inside. Its default value is 64. We can find this value here, and we can see that the hardware identifier here is 64. Therefore, the ID numbers of the two places should be the same. The ID is 1, then the connection type is 11. We fill in 1 in active established. This place has a remote address. This address is the IP address of FANUC industrial robot. We can see that it's 192.168.8.99. Then the port number of FANUC industrial robot terminal is 52. So you have to fill in 52 here as well. So here's a MB client instance instruction. It was generated when we drag this MB client instance instruction. Now, let's do a demonstration. Well, if we put in an instruction like this at this time, because our MB client instance instruction is in this function block, we need to use multiple instances in order to keep this data and prevent this data from being lost. Select multiple instances and you can see that an MB client instance 1 will appear here. Because we have dragged the MB client instruction before, we'll not click OK here, but click Cancel. Here's just a demonstration for you. Let's just delete this. This is the writing program that can be used to make model bus communication with FANUC robot. Let's take a look at program segment 1, reading the DO signal of FANUC robot. IQ here is M0.0. Disconnect is 0. MB mode is 0. MB data address is 3 1001. Then this 4 is the data length, because when we set the model bus interface of the FineCut robot, the communications time are 4, so the length here is also 4. Here we use a pointer to obtain the register address. So we can see that it starts with M100.0. And the type is byte type, which is 8 bytes. If 8 bytes are divided by 2, that is 4 words. Then the Modbus TCP here is the Modbus TCP static variable we just created. We can just drag it to the bottom. For example, we can delete it and then drag it to the bottom. Let's take a look at program segment 2, reading the high and low bit conversion of FineCut robot DO signals. Because the signal sent by the industrial robot has a problem of high and low bits. Here, we have to convert its high and low bits. We use the SWAP instruction to convert high and low bits. MW100 is a data sent by FineCut industrial robots, which is stored in MW100, MW102, MW104, MW106. We convert this data into high and low bits. The converted data is placed in MW200, MW202, MW204, and MW206. This is the process of reading the DO signals of the FineCut robot. Then the PLC side can also send signals to the FineCut robot. We call it writing DA signals to the FineCut robot. The parameter settings here are 01, 4001, 4, and here is still 8. So here is also Modbus TCP. When we send or write DI signals to FineCut robots, we also need to convert the high and low bits. So we look at the number of words written into the robot after conversion. Convert them first and then store them in MW300 after conversion. Write the data after conversion into the robot and then give them to MW302 and so on. Alright, let's look at the practical situation. Here, we give a few examples. Let's look at DI1 to DI8 and DO1 to DO10. Alright, we can see that DI1, DI2, and DI3 on the PLC side are all false now. So DI1 to DI3 on the taking patent side are also all off. For example, if we make DI1 on the PLC side 1, then we can see that the DI1 teaching device of the terminal is also 1. This is DI. Now we switch to DO. We can see that DO1 on the tech pendant side is on, and the DO7 and the DO8 are on. So the DO1, DO7, and DO8 on the PLC side are also on. We can turn DO2 to on here. And we can see that DO2 on the PLC side is also in the state of true. It means that the Modbus communication between the FANUC teaching pendant and the Siemens PLC has been completed.